Imagine a scene from industrial hell. It is a freezing night in 1910. A massive steam locomotive weighing 200 tons has jumped the tracks at 50 miles per hour. The sound of the impact was like a bomb going off. Now, twisted steel is scattered across the landscape. The boiler has ruptured, hissing steam into the cold air. The main line, the artery of the nation's economy, is blocked. For the railroad, this is not just an accident. It is a financial catastrophe. Every minute the line is closed costs thousands of dollars. The pressure is immense. But how do you move a dead giant? You cannot push it. You cannot pull it with horses. It is dead weight, sinking deep into the mud. To fight this disaster, engineers had to build a machine stronger than the crash itself. They built the steam-wrecking crane. The crews called it the Big Hook. And for 50 years, it was the only thing standing between order and total industrial chaos. In the early days of railroading, a derailment was a logistical nightmare that could last for weeks. Armies of hundreds of men would use ropes, wooden jacks, and pure muscle to try and lever a locomotive back onto the rails. But as locomotives grew larger, from 40 tons to 200 tons, human muscle was no longer enough. The disaster response had to evolve. Enter the titans of American manufacturing, companies like the Industrial Works of Bay City, Michigan, later known as Industrial Brownhoist. They realized that the railroads didn't just need a crane. They needed a tank on rails. By the turn of the century, they were producing mechanical monsters. These weren't adapted from construction equipment. They were purpose-built for violence. A typical steam-wrecking crane was a self-propelled fortress. It carried its own massive boiler, a water tank, and a coal bunker. It was mounted on a heavily reinforced flat car with thick steel trucks designed to support crushing weights. The largest of these machines, built by Bucyrus and Industrial Brownhoist, could lift 250 tons. To put that into perspective, that is the equivalent of lifting a modern Boeing 787 Dreamliner, using nothing but steam pressure and steel cables. Let's look under the hood of this mechanical savior. How did it actually work? The heart of the beast was the boiler, usually a vertical design to save space, generating hundreds of pounds of steam pressure per square inch. This steam powered a pair of reversible engines. But the real magic was in the stability. If you tried to lift a locomotive sideways without preparation, the laws of physics would be unforgiving. The weight of the load would instantly flip the crane over, killing the crew. To prevent this, the crane was equipped with outriggers, massive telescoping I-beams hidden in the chassis. When the crane arrived at the crash site, the first job was to extend these beams. They would slide out from the sides of the car, extending the crane's footprint to over 20 feet wide. Beneath these beams, the crew would stack timber blocking, heavy wooden ties, to transfer the load into the solid ground. Only when the crane was anchored to the earth like a tick could the lifting begin. The boom itself was a masterpiece of riveted steel. It was short and stubby, designed for brute strength rather than height. It didn't need to lift high, it needed to lift heavy. A machine is only as effective as its masters, and the men who operated the Big Hook were a breed apart. They were known simply as the wrecking crew. These men were the special forces of the railway. They didn't work a standard shift. They lived on call 24 hours a day, 7 days a week. When the alarm bell rang in the yard, they dropped everything. They lived on a specialized train called the wreck train or the relief train. This wasn't just a transport, it was a mobile base of operations. The train included the crane, but also tool cars filled with acetylene torches, chains, and hydraulic jacks. It had a kitchen car, because a wreck could take days to clear. It had sleeping quarters, where men would collapse for a few hours of rest before going back to the chaos. At the top of the hierarchy was the wreckmaster. He was the general on the battlefield. His word was law. He had to look at a pile of twisted metal, calculate the weights in his head, and orchestrate a plan to disentangle them without causing further damage or killing his men. Let's reconstruct a typical operation. The wreck train arrives at the scene. It is chaos. A locomotive is on its side, half buried in a ravine. The crane moves into position. The fireman stokes the boiler to maximum pressure. Black smoke pours from the stack, mixing with the steam. The noise is deafening. The hiss of the boiler, the clanking of chains, the shouting of orders. The first danger is the cables. These weren't thin ropes. They were multi-part steel cables, thick as a man's arm. As the crane took the strain, the tension would build until the cables sang, a high-pitched vibration that terrified rookies. If a cable snapped under 150 tons of tension, it became a supersonic whip. It would cut through the air and through bone and steel like a razor blade. The operator, sitting inside the hot, cramped cab, had no computer screens, no load moment indicators. He couldn't even see the load clearly most of the time. He operated blind, relying entirely on hand signals from the ground crew. One finger raised meant hoist slowly. A fist meant stop. The connection between the wreck master on the ground and the engineer in the cab had to be telepathic. A delay of 1 second could mean the difference between a successful lift and a tipped crane. Sometimes finesse wasn't an option. In the most violent wrecks, locomotives would telescope. This means one car would smash inside another, creating a tangled knot of metal that couldn't be simply lifted. In these cases, the big hook became an instrument of destruction. The crew would wrap chains around parts of the wreckage and use the crane to literally rip the trains apart. The power required to tear steel boilerplate is unimaginable. The crane would groan, its chassis flexing, the steam engine fighting against the stall point. But eventually the metal would scream and give way. Once the dead locomotive was lifted, the job wasn't over. The crane had to swing it back onto the tracks. This was the moment of maximum danger. As the boom swung to the side, the center of gravity shifted. The outriggers would dig into the ground, crushing the wooden blocking. The crane would tilt. The crew would hold their breath. If the ground gave way, the crane would topple into the ravine alongside the wreck it was trying to save. It happened more often than the railroads like to admit. For nearly a century, steam-wrecking cranes were the undisputed kings of the rails. They built bridges, they saved cargoes, and they cleared the lines during 2 world wars. But like the steam locomotives they rescued, time eventually caught up with them. By the 1960s and 70s, diesel technology began to take over. New cranes were hydraulic, easier to operate, and didn't require a fireman to shovel coal for hours before they could move. Slowly, the big hooks were retired. Some were scrapped, others were abandoned on lonely sidings, their boilers cold, their cables rusting. Today, only a handful survive in museums. Silent giants that remind us of a time when solving a problem didn't mean typing code into a computer. It meant applying overwhelming mechanical force, courage, and grit. They were the heavy lifters of history, the iron saviors. And looking at them now, you can still feel the power that once commanded the rails. Thanks for watching Titan Hall. If you enjoyed this journey into heavy industry, hit that subscribe button and let me know in the comments. Would you have the nerve to work on a wrecking crew in 1910? See you in the next one.